Assalamu alaikum. Today our topic is Zener diode. Here you can see the basic diagram showing the symbol of a Zener diode having a cathode and an anode. Now we'll talk about what is Zener diode. A Zener diode is a specially designed silicon p-n junction device that conducts current both in forward as well as reverse bias condition. If we talk about a conventional or normal p-n junction diode, it conducts current in forward bias, but when it is operated in the reverse breakdown region, it conducts current very rapidly, but hence damages the diode. That's why the normal or conventional diode is not used as a in reverse breakdown region. So for this problem, the solution is Zener diode. A Zener diode is a specially designed heavily doped diode that is used to operate in reverse breakdown region because it is heavily doped to reduce its breakdown voltage, crossing a very thin depletion layer. So it can be used in reverse breakdown region without damaging the diode. If we talk about the types of reverse breakdown in Zener diode, there are two types of reverse breakdown, avalanche breakdown and Zener breakdown. If we talk about what is avalanche breakdown, avalanche breakdown occurs in both normal and Zener diode at sufficiently high reverse voltage. It can be operated at a breakdown voltage above 5 volts, whereas Zener breakdown occurs in Zener diode at a very low reverse voltage, that is below 5 volts. If we consider a Zener diode at a voltage of 5 volts, we can see that both avalanche and Zener breakdown will occur simultaneously. Now, if we talk about the characteristics of Zener diode at breakdown region, this diagram or graph shows the reverse portion of the Zener diode characteristic curve. We can see that as the reverse voltage increases, the Zener current increases very small proportion to the knee of the curve. It is also called as IZK, Zener knee current. Now, we can see that as the breakdown effect begins, the Zener impedance, that is the internal Zener resistance, decreases with a rapid increase in Zener current, with a slight increase in Zener voltage. Now, if we talk about the ideal and practical model of Zener diode. In ideal model of Zener diode, we can see that there is a constant voltage drop where that is equal to the nominal Zener voltage. We can also see that the DC source in the diagram does not indicate the EMF because the Zener diode does not produce EMF. But the DC source in the diagram indicates the effect of reverse breakdown is the constant voltage across the Zener terminals. If we talk about the practical model of the Zener diode, it can be seen that it is a combination of Zener nominal voltage as well as Zener impedance. That is, the Zener impedance is the internal resistance of the Zener diode. Zener impedance is the ratio of change in voltage drop Zener voltage to the change in Zener current. Now we will talk about the applications of Zener diode. Zener diode can be used as voltage regulator. As we know that Zener diode is specially designed to operate in reverse breakdown region because it can maintain a constant DC voltage for a very large change in current. So, Zener diode can be used as a voltage regulator because it can maintain constant output voltage in spite of variation in input voltage or changes in load current or load resistance. If we talk about application of Zener diode as simple limiters or clippers, Zener diode can be used in AC applications as limiters or clippers as it clips the waveform in the circuit in both forward and reverse bias condition as per its position in the circuit to the desired level. Thank you.